All right, guys, we're going to work a little bit more today with kind of radical form and exponential form and switching back and forth between the two and how to use the two different formats to simplify expressions here. So yesterday we were doing rational exponents, which just means we have a fraction as our exponent. So today I'm just going to go through a couple little quick tips if you have radical form, how to convert that back to exponential. So if you guys remember what we were doing from yesterday, would tell you the bottom out is how you want to do conversion from exponential form to radical form. These questions here at the top, actually all of these in this first example, are in radical form, and we're going to put them back in exponential form. So if I reverse my bottom out, or even if you guys just want to go back to thinking about how I was telling you to simplify exponents inside radicals before, you divide the exponent by the root. So this first question would be c to the 3/4 power. So the given is radical form, and then the exponential form is when you have the exponent. Okay, now these questions are written in two different formats, which are both acceptable. So just to let you remember from yesterday, I could also write this exact same expression this way, where I would have the b to the 5th power, or you can put parentheses around the root and the power on the outside. Regardless, the conversion to exponential form, I'm going to divide 5 by 3. The index of the root, this little number on the outside, is always going to be your denominator. Okay, now the next one is very tricky. So this is a square root, so they don't write a 2 in there, so I'm just going to write that in for that question. The reason this is a tricky problem is the way that it's written, and you can see I have similar problems following here. The only thing being taken to the 5th power there is the a. So I want to think about this as 6 to the 1st. There's no parentheses in there, so the 6 does not have an exponent of 5. I'm just going to put a little 1 in there. So this is the square root of 6, which would be 6 to the 1/2 power. And then since a to the 5th, we would do 5 divided by 2 to get that simplified there. So that would be a separate problem. Now, this is in parentheses. So the whole thing is to the 5/2 power. So it would be 6a to the 5/2. And then the final question, everything in here, we have the square root, the parentheses are around the whole thing, so being taken to the 5th power, the whole thing there, this is going to be equivalent to that previous question. These two are the same, just two different ways to write this, but because there's parentheses around this whole thing, we're going to assume both of those are being taken to the 5th power, but after we take the square root. So this one would look exactly the same as the previous question. And honestly, if you guys wanted to, you could write this, both of these, 6 to the 5/2 times a to the 5/2. Either one of those formats is fine with me. Okay, now we're actually going to do something a little different in these next two questions because we're going to multiply. These were just single expressions up here. So I'm going to convert this to exponential form here real quick. So this would be 2 to the 5/6 power times 2 to the 5/3 power. Now, because both of these bases are the same, we can actually simplify this. And if you remember, when you multiply like bases, we're going to add the exponents. The only thing that's going to be tricky here is I'm going to need to add those two fractions, and to do so, we have to have a common denominator. So let me just come up here. 5/6 plus 5/3. I could get a denominator of 6 by multiplying the top and bottom of this second fraction by 2. So I'm really just multiplying by 1. And when I do that, we're going to have 5/6 plus 10/6. Common denominator allows us to add that, be 15/6. Notice the denominator stays the same. Now I can do one more little thing here. Both of these numbers are divisible by 3, so I can actually reduce that fraction, 15/6. So 15 divided by 3 is 5, and 6 divided by 3 is 2. So ultimately, once I get that simplified, my exponent should be 5 over 2. So back over here, my answer, 2 to the 5 over 2 power. And it does say leave it in exponential form, so that means I want to see an exponent. We don't want to convert that back into radical form, which would have a root of some kind. Okay, similar problem here. This is 5 to the 5/3 power. Now, this would be a square root and 5 to the first. So square root is always the same thing as the 1/2 power. So similar concept here. We're going to add these exponents, and to do so, again, I need a common denominator. Now, between the denominators 3 and 2, I think our common denominator is going to be 6. So I would do top and bottom here by 2 and top and bottom here by 3. So I'm going to get 10/6 plus 3/6, and then we can go ahead and add. Unlike the last question, that doesn't reduce. So my exponent, once I do the addition here, should be 13 over 6. So that's what I'm going to write down as my answer, 5 to the 13 over 6 power. And I should have mentioned this in the last problem. Both of these, don't change that exponent to a mixed number, just leave it as an improper fraction. That is the best way to do those questions. All right, now we're going to just continue this process. This does say we want to leave our answer in simplest exponential form. And again, want to try our best to do these without a calculator, because we're not going to allow you guys to use calculators on the quizzes and tests for the questions pertaining to this topic. So power to a power, I'm going to multiply my exponents. But I also have a product within the parentheses here, so everyone gets that 1/4 power. So 81 to the 1/4. When you do 28 times a fourth, you just do 28 times 1 divided by 4. So this actually becomes x to the 7th. That's divisible there. Negative 20 times 1/4, I do negative 20 times 1, that's negative 20, divided by 4. That's going to give you an exponent. Oops, sorry, I should have mentioned the negative, y to the -5th. Okay, now, there's a couple things I can do here. I'm going to try to simplify that 81 to the 1/4. Now, to me, since I can't use my calculator, let me convert that to radical form real quick. I'm going to do the bottom out. So, 4th root of 81 to the 1st, or just the 4th root of 81. And if you're not familiar with this, if you look at your column that's got the perfect fourths, you'll notice 81 is the 3rd one down. So this is going to be a nice number. This is actually just equal to 3. And then I can't really simplify too much else in that expression other than I do need to move that negative exponent. So just take, and we're going to keep the 3x to the 7th on the top. Move it and lose it, that negative exponent. When I move it down to the bottom part of the fraction, it becomes positive. And this would be my totally simplified answer, and it's in exponential form. You'll notice I don't have any radicals as I wrote my final answer to the question. Okay, so let's try another one. Product, everything gets this negative 1/5 power. So 32 to the negative 1/5. Okay, now 30 times negative 1/5. So I'm going to do 30 times negative 1, that'd be negative 30, divided by 5 would simplify to be negative 6. So we got some negative exponents here. Y to the 10th, 10 times negative 1/5. 10 times negative 1 is negative 10, divided by 5, this will be negative 2. Okay, the whole mess here is going to need to move because I've got negative exponents. So everything moves down, and when we move it, we lose it. Now, I can't leave nothing in the top because the top exists, so we'll leave a 1 on the top. So 32 to the, 1/5, that's a 5, pretend. Oh my, let me just start over again. Okay, 32 to the 1/5, x to the positive 6, y to the positive 2. And then the only other thing we want to check here, I want to see if I can simplify this 32 to the 1/5 before I write that down as my answer. So I'm going to convert that to radical form real quick. This 32 to the 1/5. Bottom out, that would be the fifth root of 32 to the first. And if you guys check this out under your fifth root, 32 is the second one down, so the fifth root of that, this is actually just equal to the number 2. So my final answer, 1 over 2x to the 6, y to the second. And forgive me, I'm going to scooch this up so you can see that. And then we'll just do one more, and then we'll flip to the back. We're just practicing kind of a little bit of application of what we did yesterday to make sure you guys understand this. All right, so I'm going to distribute my exponent to everything inside of there. So we have 8 to the negative 2/3. Power to a power, we're going to multiply those exponents. So 3 times negative 2, let me slide that down so you can see it. Sorry, 3 times negative 2 is negative 6. Divided by 3 is actually going to give us x to the negative 2. Negative times a negative is going to make this exponent on the y positive. So negative 18 times negative 2 is going to turn into positive 36. Divide that by 3 and you will get 12. All right, so I got to move a couple things. These guys both have negative exponents, so we're moving those down. So I have y to the 12th over 8 to the positive 2/3, move it and lose it, x to the positive 2. And then the only other thing I got to check out here is, can I simplify that 8 to the 2/3? We're going to see if we can break that down any further. So bottom out, this would be the third root of 8 squared. Now, the third root of 8 is actually just the number 2, and you can think of it this way if you want to. I like to do the root first. It usually makes me deal with a smaller number. So the third root of 8 is 2, but then we have to square that. So ultimately, 8 to the 2/3 power is going to end up being 4. So I'm going to put that back in, as that would be the simplest form. So this would be y to the 12th over 4x squared. All right, our next example is going to want simplest radical form. So I want to see a root of some kind when I simplify these. But if you guys remember, when I multiply, they have to be the same type of root for me to multiply. So since that's not the case here, this is a third root, this is a fifth root. What I can do though, let's convert these to exponential form real quick. So it'd be t to the 4/3 power times t to the 8/5 power. And then I can do this problem because I have like bases, they're both a t. If I multiply like bases, what we want to do is add the exponents together. The only tricky part to this is to add fractions together, we have to have a common denominator. So to do that for this question, I think we're going to be using 15 as our lowest common denominator. So top and bottom here by 5, top and bottom here by 3. So I've got, let's see, 20 over 3 plus 24, I don't know why I just said 3, sorry, 20 over 15 and 24 over 15. Now add those guys up, you're going to get 44 over 15. That does not reduce, so that's going to be my exponent. I'm going to slide this up just so I have a little bit more space. Okay, so here's all my work for my fraction. This is going to be kind of tricky, guys. Now, this means this is t to the 44/15 power. Okay, that fraction does not reduce. And the question, if I move this back, asked you simplest radical form. So I have to put it back in a format where I have a root. So I'm going to do my bottom out. This is going to be 15th root of t to the 44. Okay, now it's been a minute since we've done this, but that can be broken down. 44, it's not going to exactly go into 15, but you can break this down. So I'm going to try to get the biggest number I can that will divide into 15. So let me rewrite this real quick. Numbers that go into 15, you got 15, 30, 45. I'm going to rewrite this as t to the 30th times t to the 14th. That would add back up to that 44. Now, 30 is divisible by 15. So what's going to happen here? This is just going to come out as a t squared out in front, and then we can't break that down any further, so it'll be left underneath. So it'd be t squared times the 15th root of t to the 14th. That's kind of a big number there, but that would be the broken down version in radical form, simplest radical form. So we're going to try this again with a little different example. Let me do the same thing. I want to first, just easiest thing I can tell you to do. I can't multiply a square root and a fifth root together, but we can convert it to exponential form and see if we have like bases. So if I don't have an index here, it's implied that it's a 2. It's going to be a square root. W to the 9 over 2 times W to the 11 over 5. I do have like bases. Those are both a W. So what I need to do there is add those exponents, and I need a common denominator. So lowest common denominator I'm going to get between 2 and 5 is going to be 10. So top and bottom here by 5, top and bottom here by 2. We're going to end up with 45 over 10 plus 22 over 10. We're going to go ahead and add those because now I have a common denominator. 45 and 22 is going to add up to 67. All right, so kind of here's my fraction work here. So if I back up where we were at, very similar to the last problem, we're just practicing this a second time. I need radical form. The directions back up here said radical form. So this is exponential form. So to get my radical form, we're going to bottom out. So 10th root W to the 67th. Now 67, 10 will go into that, not evenly, but we can break this down further. So numbers that go into 10, 10, 20, 30, 40. The biggest number I'm going to get out of this is going to be 60. So W to the 60th, and then I need 7 more to give me back that 67. And then we're just going to go ahead and simplify this. This will become out as W to the 6th, and then left underneath that 10th root, W to the 7th. And I have one more in this example, and then we'll do something a little bit different in the bottom. So this question is division, and again, you can't divide unless they're under the same type of root, which they are not here. I have a 4th root and a 5th root, so my option here, let's convert this to exponential form. So I'm going to reverse the bottom out process, so this would be q to the 9/4 over q to the 8/5. Now, these are like bases. Those are both the q. If you divide like bases, what you're going to do is subtract the exponents. So 9 over 4 minus 8 over 5. Now, just like adding, when you subtract fractions, you do need a common denominator. Between 4 and 5, the lowest common denominator I'm going to get is 20. So 5 and 5, 4 and 4 here. This is going to be 45 over 20. And let's see, this is going to be 32 over 20. We'll go ahead and subtract that. That's going to give us 13 over 20. All right, so here's my fraction work there. So this would be q to the 13/20ths. Now this is actually going to be nice for us because when I do my bottom out, I have the 20th root of q to the 13th, or if you prefer, you can write it like this. Those are the same, but that is not going to break down because 13 does not, there's no number that's going to go in for 20, so we don't have to do an extra step on that question like we've done on the last two. And my last question, we're just going to use some properties of exponents, and we're going to determine what a is going to be. So right here, power to a power, we're going to multiply the exponents. So 3 times 1/5 would be 3/5. And then I've got radical form here. Remember, if you don't have an index, it's implied to be a 2, so this is a square root. If you don't have an exponent there, just think of that as being to the first. So the square root is the same thing as the 1/2 power. we're supposed to define what a is there. So multiply like bases, we're just going to add our exponents. And again, to do this, I do need a common denominator. And I'm going to get 10 to be the common denominator for this question. Top and bottom of 3/5 by 2, top and bottom of 1/2 by 5. You're going to get 6/10 plus 5/10, so 11/10. And this question is saying this equals x to the a, so I just need to say what the exponent is to answer the question. That's going to be that 11/10. And I've got one more problem here, and this one's going to be a subtraction. So power to a power, we're going to multiply those exponents. That top of that fraction would be x to the 3/4. The bottom of the fraction, again, if you don't have an exponent, just think of that as being a 1. The 4th root is the same thing as the 1/4 power. This one will be super nice for us because I don't even need to get a common denominator. I'm going to have one. So 3/4 minus 1/4 would be 2/4. Each one of these x to the a. Now, the only other thing I can do here, 2/4 does reduce to 1/2. So there, my answer to the question is what that exponent would be, and a is going to be 1/2.